Hello, welcome to this video. This is the first lesson of grade 8 integrated science for online tuition in our channel, and I hope you are excited to learn a few things here and there. The lesson has 17 questions, and I hope you are able to access the questions beforehand so that you attempt how you are going to attempt or you are going to learn integrated science is a little bit different from mathematics. Remember, mathematics is a doing subject where as we are learning, I can send the assignment beforehand, you do, and then we do with you. However, during the lesson, I can ask you to pause the video, do the questions that I give on specific points of the video, and you mark against what I've done. In integrated science, you will not require to keep pausing the video along the way as you are watching. So you are required to access the paper, do all the questions. I can also give the whole paper just at the beginning of the video so that you can go through the questions, attempt them, all of them, then watch the video. Even if you feel the paper is quite easy, just watch the video because there are many things you are going to learn along as you watch the video. I might add things outside the paper because the purpose of revision is not specifically to answer the paper that you have, but rather to help you grasp content and also enable you to answer any question. So I'll be explaining the different ways questions can be twisted as you watch this video so that you are all round ready for the exams. Remember, the best way to revise is by use of questions, and therefore we are going to use many questions while revising in this and also upcoming videos, so that by the time you are sitting for your exams, you have come across most of the questions, if not all. Actually, do you know by the time you are doing your KJSEA, if you start our tuition, if you have a year or more in our tuition, you are going to meet all the questions that we have tackled in our videos in your final exam, and it will be very easy for you. So you can always come back to watch and rewatch this video. Remember, through repetition is when you grasp content. However, as we do these different papers, you'll find that some questions are repeated. So again, you're going to understand the concepts even better. So welcome to this lesson, and excited to hear your comments in the comment section. You can also answer some of the questions that I've asked during the lesson for you to answer in the comments so that you can all learn and share with other learners in this platform. Thank you. Enjoy your lesson. The first question reads, define the term integrated science. This term should be defined as that integrated science is an interdisciplinary approach that combines multiple scientific disciplines such as biology, chemistry, and physics into one field of study. Note that different books could give slightly varying definitions. However, the key terms include that you are going to combine. It's a subject. Sometimes you can say it is a field of study or it is a study area that combines scientific disciplines such as biology, chemistry, and physics into a unified study or field of study. So look at this simple definition. You can get it, or you can take the one that you feel is simpler from your books. The second question asks, state 3 components of integrated science. As mentioned in the definition, the components of integrated science are biology, chemistry, and physics. Those are the 3 components of integrated science. The third question reads, state and explain 4 basic science principles. State and explain 4 basic science principles. These are basic science skills, not principles. Basic skills, these are skills that you need to conduct research and also to make conclusions in this whole topic of or study area of integrated science, both chemistry, biology, and physics. The first is observation. Observation, you are told to state and explain, so therefore you are supposed to answer in totality, don't just state. Observation is the first basic skill. This involves using the 5 senses to gather information about objects and events. What are the 5 senses? These are the 5 basic senses. Example, taste. Sometimes you'll need to taste some chemicals, not all, some chemicals, and tell that they are sour, for example, or they are sweet tasting. You need eyes, sight. What do you see? Do you see the color of a chemical? You also need to touch and feel the texture. Sometimes you will need to hear, and sometimes the smell. So the 5 basic senses are important in observation. The second basic skill is classification. In all the 3 science components, chemistry, biology, and physics, you will need to understand classification, or you need that skill of classifying objects. But what is classification? Classification involves grouping objects or organisms based on shared characteristics or properties. In biology, you classify animals, some into mammals, others as birds, others as amphibians, and so on and so forth. So that is classification. And if you go to senior school, you learn deeper about classification and the 7 taxonomic units of classification, from kingdom, plant, time, and animalia, and the rest, going down to the species. The third skill you need is measurement. But what is measurement? Measurement involves using standard tools and units to determine the dimensions, volume, or mass of an object. You measure distance, you measure the size, and so on in science, sometimes volumes of chemicals. The 4th basic skill is prediction. Science relies on ability to tell what the future holds, or estimating what might happen in the future. So here, we are going to make prediction involves making an educated guess about a future outcome, often relying on current observations or data. You look at what is happening today, or what you observed today, so that you are able to predict the future. The next question, we are asked to state 2 laboratory apparatus used for heating. So in the laboratory, what apparatus do we use to heat or chemicals? So the most basic one is the Bunsen burner. That's the obvious. However, in the case you do not have a Bunsen burner, what else can you use? You can use a spirit lamp. In the event you do not have a spirit lamp, or maybe based on your preference of the setup of the experiment, you can use a candle. You can use a candle, and lastly, you can also use a kerosene stove. So those are the 4 main apparatus you can use for heating in the laboratory. The next question: differentiate between homogeneous and heterogeneous mixtures. Homogeneous and heterogeneous mixtures. This one you can understand from the naming. Both are mixtures. One is hetero, the other one is homo. Homo means one. So therefore, homogeneous mixtures have a uniform composition throughout, and you cannot tell the individual composition. Like when you mix milk and water, you cannot tell milk, there is milk here, or you cannot point milk and point water separately because it has mixed completely. The same with salt solution. After you have mixed salt with water, you cannot then identify and tell, I can see salt in this water. It is uniformly mixed. What about heterogeneous mixtures? This form have a non-uniform composition. Also, the individual components are easily distinguishable. For example, if you mix maize and beans, you can tell when you look at maize and beans, you can tell maize there and beans is on this other end. The same with the sand and water. If you mix sand and water, you can easily tell there is sand there and there is water on another end. So that's how you can give as many examples. In the comment section, give more examples of homogeneous mixtures and heterogeneous mixtures, and we can continue engaging both you, the students, and I, and also comment below other students' comments, and we learn together. Hi, so question 6 was asking about finding the volume of a carbon box. Volume of a carbon box, which is cuboid in shape. So this carbon box, we are told that the length is 10 centimeters, 4 centimeters, that is the width, and then the height was 8 centimeters. 8 centimeters. We know that volume of a cuboid is given as length times width times height. So you had 10 times 4 times 8, which is, this is 32, 320 centimeter cubic. And you are also asked to give your answer in standard SI unit. So the SI unit of volume, SI unit of volume is meter cubic, not centimeter cubic. So you convert this. There are 2 ways you should have done this. You could have done the volume in centimeter cubic and then convert, or you convert this to meters. So how do you know that I have told you that 1 meter cubic is equals to 1 million centimeter cubic? But I do not want you to cram this figure. Just note that if you had a cube, if you had a cube that was 1 meter, 1 meter, and 1 meter, the volume, let me write in with a different pen, the volume would have 1 times 1, would have been 1 times 1 times 1, 1 meter cubic. However, convert this into centimeters. 1 meter is 100 centimeters. So volume again, in terms of centimeters, would be 100 times 100 times 100 would have been 1, and then how many zeros? 1, 2, 3, 4, 5, 6 centimeter cubic. So indeed 1 meter cubic is equals to 1 million centimeter cubic. So I wanted just to prove that so that you do not cram. Back to our question. So if then 1 meter cubic is this, what about 320? You write towards the side that has the centimeter cubic. You ask what will happen here. So you cross multiply. You have 1 times 320 all over this one comes down. So this is 0.00032, because the first 3 zeros will cancel this and take the decimal here. Then this will add 3 zeros. Meter cubic. This is the answer. Alternatively, if you do not want to use this conversion, you could have changed this into meters. 10 centimeter is equivalent to 0.1 meter. This is 0.04 meter. This is 0.08 meters. So, and then the volume would have been let me write here. Volume is length times wind times height. Would have been 0.1 times 0.04 times 0.08. And your answer would be, you multiply without the decimals, then you add the decimals later. So you would have 32. However, we have how many decimal places? 1, 2, 3, 4, 5. So you would go 1, 2, 3, 4, 5. This would be the answer. So whichever method you would like, you can use either. However, I hope you have understood the conversion and everything. Yes. We also have this question. Describe how you can separate water and ethanol. We are on the same topic. We are still in the topic of mixtures. How can you separate water and ethanol using fractional distillation? The first thing you need to ask yourself when you are given such a question, especially when they have specified about the method fractional distillation. We know fractional distillation is based on the knowledge that the mixtures involved have different boiling points. In this case, we know ethanol and water have different boiling points. We know the boiling point of water is 100 degrees Celsius. What about the boiling point of ethanol? It is usually 78 degrees Celsius. So now we know when you heat that ethanol will evaporate fast or will distill in this case. So you can write you have 4 marks, so you have to really elaborate well. So the first step to gain the first mark is first to place the mixture in a flask and heat it. So you are placing the mixture in a flask, of course in the flask with distillation, fractional distillation setup, you heat. The second step is, our concept is, since ethanol has a lower boiling point, in brackets 78 degrees Celsius, than water, which is 100 degrees Celsius, ethanol evaporates fast. The third point, ethanol vapor rises through the fractionating column and enters the condenser. Remember that's fractional distillation column or setup. You'll have the Liebig condenser where ethanol vapor rises through the fractionating column and enters the condenser. The vapor cools and turns back into liquid ethanol, which is collected in a separate beaker, while water remains in the original flask. That's how you separate the two. Easy. The next question, briefly describe the menstrual cycle from day 1 to day 28. You have learnt about the menstrual cycle. from day 1 to day 5, what happens? Menstruation occurs. This is the shedding of the uterine lining. This is responsible for the menstruation or spotting. Remember, note that the first day of spotting is the first day of the periodic cycle or the menstrual cycle. The first day of spotting, and that's why we are saying between the first day and days 1 and 5 menstruation occurs. Day 6 and to 13, the uterine lining begins to thicken again and an egg matures in the ovary. Day 14, ovulation occurs. The mature egg is released from the ovary. Day 14 is the ovulation day. Days 15 to 28, the lining continues to thicken to prepare for possible pregnancy. If no fertilization occurs, then the cycle restarts. So if no fertilization occurs, the cycle restarts again with the shedding of the uterine lining, and then goes on and on. Something just to note, this is important. These days are the general days for the menstrual cycle. However, due to many factors, maybe hormonal changes or also from one person to the next, the menstrual cycle may be different. Like this one, the general one is 28 days. Some people experience a menstrual cycle of 26 days and others 29. And yes, so it is important to understand that there may be some variation. Also, others experience menstruation for less than 5 days. Others experience for 3 days. Also depending with the stages in life and many other factors, medication. Okay. The next question. State 3 causes of kidney disorder. 3 causes of kidney disorder. 1. Kidney disorder can be caused by infections. This is urinary tract infections, or referred to as UTIs. This may spread to the kidneys. Remember, UTIs affect all parts involved in the urinary tract, along the urinary tract, from the bladder, urethra, and even can go even to the kidneys. Another cause for kidney disorder is high blood pressure, hypertension. Note that all the blood in the body passes through the kidneys for excretion, and therefore when blood is pumping at high pressure, then it affects the kidneys functionality and therefore can cause a disorder. The third cause is diabetes, high blood sugar. This can damage the kidney filters. You have learned about osmosis, physiological processes in cells and tissues. Now, one of the ways that waste is excreted through the kidneys is by use of osmosis and diffusion. So when diabetes, high blood sugar, is present in your blood has high blood sugar level, this affects osmosis and also diffusion. So if it does, then it may damage the ability of the kidney to filter out waste and retain useful substances. The next question, state 3 sources of electricity in our environment. State 3 sources of electricity in our environment. One source of electricity is solar power. The sun is a source of electricity. Solar power in form of sunlight is tapped through solar panels, and we have solar power. The other one is hydroelectric power. This is tapped from moving water. This is the most common form of power or electricity tapped or generated in our country and our region generally. Other countries will have will even rely on, it's called nuclear energy. In Kenya we do not have nuclear energy. The other source of electricity in our environment is geothermal power. This is tapped from the earth, in the Rift Valley especially. Lastly, we have wind power. We can tap wind from our environment. Yes. And you have several. Now, the next question. State 2 effects of force between charged objects. State 2 effects of force between charged objects. One effect after you charge objects, one, it could lead to attraction, because unlike charges pull toward each other. If you charge two objects differently, that one is positively charged, the other one is negatively, they will attract each other. On the other hand, it could affect them and cause repulsion. Repulsion, where like charges tend to push away from each other. So if you have one that is positively charged and you bring another positively charged, they will repel. And this, the best example to give would be that of a magnet. We know the North Pole repels the North Pole, South Pole repels South Pole, but North Pole attracts South Pole. Yes, unlike poles attract, like poles repel, and the same way with charges. Give two properties of solids. Give two properties of solids. You need to understand the differences between solids and gases and liquids. Solids, we know they have a definite shape, that they do not take the shape of the container. This one, even if I put it in a container, it will always remain of this shape. And the same with this one. This one will never change its shape. Will not change its shape by putting it in a different container. However, water, liquids and gases take shape of the container they are put in, and therefore they do not have a definite shape. Solids have a definite volume. Solids have a definite volume. They are, however, gases do not have. What about liquids? Liquids do. Most liquids have definite volume. A few can be compressed. The last property is that solids cannot be easily compressed. Because particles are closely packed. Particles are closely packed, and therefore you cannot easily compress solids. The next question. Identify 3 characteristics of temporary physical changes. 3 characteristics of temporary physical change. An example of temporary physical change is evaporation and melting, or freezing. When you take water and you put it in a freezer, it becomes solid. It can easily go back to liquid. So when you think about that, you will be able to answer that question easily. One characteristic of this is that the change is easily reversible. You can easily reverse. This change. When water changes into solid, it can easily go back. Or when it evaporates, you can easily tap it back and condense it back to liquid. The other thing is that while these changes occur, there is no new substance that is formed. When you melt solid ice cube, it is still water. The properties are the same. And the last one is chemical properties of the substance remain the same. Chemical properties of the substance, whether in different forms that undergo temporary physical change, will always remain the same. Great. The next question we are asked, state 3 applications of change of state of matter. State 3 applications of change of state of matter. So just what we have been discussing in the previous question. 1, freezing. We can apply it. We can apply the concept of freezing in making ice cubes. So making of ice cubes relies on the change of state of matter. Another one is ironing clothes. Some iron boxes rely on or use steam to better iron clothes. They heat water, they produce steam, and therefore making it easy or more convenient to iron clothes. The last question, drying clothes in the sun or also in dryers, you use evaporation. Water changes from liquid to gas. You can list many other examples in the comment section. The next question, identify symbols of the following elements. Identify symbols of the following elements. We are given aluminium. Aluminium, the symbol is Al, capital A, then small l. Note that is L, small l. B, we have iron. Iron, the symbol is capital F, small e. C, silver, the symbol is Ag. Gold, Au. When you have an element with the two symbols like all of this, you start the capital. The first is with the capital, the second one a small letter. So I'm going to attach a video here discussing many other elements so that we do not only learn this, so that the next time they bring another set of elements in the exam, you'll be able to get it right. Yes. So the symbol for aluminium is Al. We have the other one is iron. We also have silver, and we also have gold. The chemical symbol for iron is, the chemical symbol for silver is, the chemical symbol for gold is. So note that there are some symbols, there are some elements whose symbol is similar to the English name, but these ones are derived from the Latin names of this. For example, iron is ferrum, and so on and so forth. So this aluminium is Al. I had mentioned that there are other elements that are common, the first 20 elements. How do you list the first 20 elements? Let us do this so that you do not forget. To remember the first 20 elements as they follow each other, you sing this song or an acronym. The first one is hey, he, listen, B, C, news, on Friday night. So the first 10. The other one is Friday night. 6 ministers arrested. 6 people suspected committing a political crime. So these are the other 10 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm going to write the full name of these elements, and then you can write the chemical symbol. So here, or I write the chemical symbol and you write the full name. However, it is important you note the sound. We are using the sound, not the chemical formula. So this is hydrogen, right? In your book, you can write this in going down. Don't write 2 columns. Have this column where you have this is the sound, full name of that element, and then symbol. So I'm going to skip the full name and write the symbol for you, because I'm going to mention it anyway. This is hydrogen, and then the symbol is H, because I want you to get the symbol very correctly. This is helium, and the symbol is He. Remember, they should not touch each other. Capital H, then E. Lithium is Li. This is beryllium, BBC. When you have 2 that are similar, you should know which one comes first. Beryllium, and then you have boron. C is for carbon. News is for nitrogen. On is oxygen. F is fluorine. And then N is neon. When you are able to draw the periodic table, it becomes even easier. You can watch my video on this channel about the periodic table, lesson 1, 2, and 3. You are going to learn well, especially lesson 1 has this. This one is sodium. So you write the name and then symbol. So I'm going to write the symbol now. Sodium is Na. Ministers is Mg. This is aluminium. This is silicon. Phosphorus, sulfur, chlorine, capital C, argon. We have potassium, and then we have calcium. So political is for potassium, and the symbol is K. We had people. This is phosphorus. This is sulfur. When you have several S, and S, the first one is sodium, the second one is silicon, and lastly we have sulfur. When you draw the periodic table again, you are going to understand even better why these elements fall where they do. So I'm going now to give you there are several elements that I've mentioned. You can write the chemical symbol, the likes of tin, copper, and the rest. You can, and lead, and manganese, and the rest. You can write in the comment section so that we check how well you have done your assignment and how well you have understood these concepts. The next question, state whether the following statements are true or false. State whether the following statements are true or false. The first statement is hydrated copper 2 sulfate is red in color. Is it? We know hydrated copper 2 sulfate is blue. Blue. What about anhydrous copper 2 sulfate? Remember, this is used to test for the presence of water. You take anhydrous copper 2 sulfate, you add a liquid that you want to test whether it's water. If it is water, it turns blue. So anhydrous copper 2 sulfate is color white. It is white. Good. Now you have learned something. What about part B? Anhydrous cobalt 2 chloride is black. Is it? It is not. Note, anhydrous copper 2 sulfate is blue, and it is also used to test for the presence of water. Now anhydrous is blue. When you add a liquid or you add water, if the liquid you are adding is water, it turns from blue to pink. From blue to pink. Other books might say red, but it is a pink. Note that anhydrous copper 2 sulfate is blue. Anhydrous copper 2 sulfate. I've said anhydrous cobalt 2 chloride is blue. Anhydrous copper 2 sulfate is white. Hydrated cobalt 2 chloride is pink. Hydrated copper 2 sulfate is blue. You have learned something. Don't say that both are blue when they are hydrated. No. One is blue when it is hydrated, the other one is blue when it is anhydrous. Excuse me. Part C. Gases can be compressed. Is it true or false? Very true. Gases can be compressed. Solids cannot, and liquids can sparingly be compressed. The next question. Differentiate between an element and a compound. Differentiate between an element and a compound. An element is a pure substance that cannot be split any further using any chemical means. So, the first thing to say is that it is a pure substance and that you cannot split any further using any chemical means or any further to get other components. An example of an element: iron, oxygen. The first 20 elements, all of them you can say sodium, magnesium, calcium, chlorine, neon, argon, all of them. These are elements. You cannot split oxygen further to produce any other thing. Yes. However, the element can have atoms, but all atoms are of the same type. Therefore, another definition you can say an element is a pure substance made of only one type of atom that cannot be broken down into simpler substances. What about a compound? What is a compound? A compound is a substance made of two or more different elements chemically combined in a fixed ratio. A compound is a substance made of two or more different elements chemically combined in a fixed ratio. An example: note, a compound is not a mixture. Mixtures, the components are not chemically combined and that the ratio is not fixed. For example, you go to someone who has cooked maize and beans, and you go to a different person, you find the ratios of beans to maize is different. Therefore, those are mixtures. And also you can identify the components. Anyway, so here, a very common example of a compound is water. Water contains hydrogen and oxygen. The chemical formula we write H2O. H2O. Another example of compound is salt, table salt. Its chemical name is sodium chloride. It has sodium and chlorine that have reacted in a fixed ratio. For example, H2O, we are saying 2 atoms of hydrogen react with 1 atom of oxygen to form H2O. Another ratio that is simple to understand is CO2, carbon dioxide. CO2, 1 atom of carbon attaches or reacts with 2 atoms of oxygen to form carbon dioxide. That is a compound. So you can discuss and mention various elements and compounds under the comment section. Thank you. We have come to the end of the lesson. Thank you for watching this video. I invite you to continue engaging with our content so that through your consistent appearance in our classes, you'll be able to learn many things. So this is just one of the many videos on integrated science that you'll access here. Thank you. See you in the next lesson. Hi there. Have you subscribed to my YouTube channel? If you have not, chances are you are going to miss my next YouTube videos. So please subscribe and turn on the notification bell so that whenever I upload a new video, you'll be among the first to see my video.